To understand this work, we need to know the exact meaning of the terms interaction commands, incremental programmer difficulty, and predictions. Let us start with interaction commands. Interaction commands include commands submitted to the programming environment, such as the paste command here, along with their timestamps. They also include web search strings used and the web links followed, again with their timestamps. Difficulty status gives the level of the difficulty, whether surmountable or insurmountable, and the kind of the difficulty, whether the problem is designing a solution, understanding an API, or getting the right output. Incremental means the exact time of the difficulty is given rather than a course time range. We want exact times so that we can design and evaluate difficulty detection modules that make instantaneous difficulty predictions based on the interaction commands. So is this new data? Programming logs have been collected before, but to predict interruptibility rather than difficulty. Problem difficulty has been determined before, but after the task and not during the task. And it has been associated not with actions taken by the programmer, but with their physical attributes such as eye gaze. As far as we know, no one has associated interaction logs with incremental difficulty status. This means that we have to use a fundamentally different technique for gathering difficulty status. The approach we used was based on an iterative plan in which data for a new predictor was based on corrections made to the predictions made by a previous predictor. Let us see this approach in action. Here, the tool from a previous iteration predicts a difficulty. At this point, the programmer can do nothing, say that this was a false alarm, or ask for help, in which case a dialog box is presented to describe the difficulty. Of course, it is possible that the programmer does not correct an erroneous prediction and not ask for help. Therefore, we have developed a tool to allow observers to watch programmer recordings, find the points at which developer actions or inactions indicated difficulty, and give their interpretation of what happened. So we have both developer and observer perceptions of difficulty, and we have used various combinations of these data in our evaluations. The idea of a help button makes sense only if we have a lab task in which help is always available. The task we used was a visual task in which two views of a model, a graphical view and a text view, were kept synchronized as the model was moved, resized, and reconfigured. We have data from 16 subjects who performed this task. We have extracted high-level features from these data described in this thesis. We have developed an interactive tool that allows feature parameters to be varied for various combinations of participants in the task. We've also built a tool that shows the values of these features at different times, along with the predicted difficulty level, the actual difficulty level based on corrections, and the type of the difficulty, whether it is a design barrier, an API barrier, or has to do with incorrect output. This tool allows one to travel through the timeline and focus on selected features. Okay. We have fed the promising features to the WEKA tool to get the results we have published. The data we have gathered and inferred, along with the code we have written to gather, visualize, and analyze the data, are available at this GitHub repository. You can use this material to validate our results, select better data mining algorithms and features, and even perform new experiments.